Hello, I am Maaike van den Boomen, the corresponding author of this meta-analysis paper on native T1 reference values for non-ischemic cardiomyopathies and populations with increased cardiovascular risk. This paper is recently published in Journal of MRI, and you can find it under the DOI on the screen. Non-ischemic cardiomyopathies are a growing problem and are difficult to diagnose until they already progress too far to actually treat. Here you see a normal heart on the left in comparisons with the heart that's dilated, hypertrophic, restrictive, with a restrictive cardiomyopathy. This last restrictive cardiomyopathy is often defined with other causes, such as amyloidosis, myocarditis, iron overload, or Fabry disease. Several populations with increased cardiovascular risk show similar characteristics as the cardiomyopathies that I just showed, and this makes it very difficult to determine whether it's a change due to the risk or a change due to the cardiomyopathy. Examples of these populations that have those characteristics are people with hypertension, diabetes, or obesity. This meta-analysis is focused on whether native T1 mapping can help to diagnose those non-ischemic cardiomyopathies, and if it might even help to distinguish the described risk populations from the cardiomyopathies. To do this, we did a systematic research on PubMed and Embase to studies that used the MOLLI or SMOLLI sequence in the described populations, so the non-ischemic cardiomyopathies and the hypertension, diabetes, and obesity populations. We used a random effect model to define the standardized mean differences and the heterogeneity. We used a meta-regression analysis for publication and sensitivity analysis, and we also defined the main covariates from these meta-regression analysis, and we used that in the mixed effects model to see whether the changes are significant or not. We used a Prisma approach to exclude or include papers, and we ended up with a total of 45 papers that we included for the meta-analysis. So for the meta-analysis, we basically looked at the standardized mean difference of the native T1 values by the random effect model. And we see that for hypertrophic cardiomyopathy, the native T1 values significantly increase, but there's a very high heterogeneity in those studies, and this was mainly caused by the MR offenders and the age of the included subjects. For dilated cardiomyopathy, we also see a significant increase in T1, and the main causes of the heterogeneity here were because of based on the number of men included and the age of the studies, the subjects that were included in the studies. For the restrictive cardiomyopathies, we saw an increase in T1 for the myocarditis population, with again the fender and the left ventricular ejection fraction as main causes for the heterogeneity. For iron overload and also for amyloidosis and also for the Fabry disease, we saw a significant increase or decrease of the T1, but we couldn't do any meta-regression analysis because we only had a small number of studies that we included for these groups. For the hypertension populations, we see some increase of T1, but that's not very convincing. So we looked at the causes for heterogeneity, and those were the fender and the left ventricle ejection fraction. And based on this, we decided to split the hypertension populations in two. So we looked up the hypertension population without any left ventricle hypertrophy, and we looked at the hypertension with this left ventricle hypertrophy. So we saw that for hypertension without this remodeling, there was no significant change in T1, while for the hypertension with this left ventricle remodeling, we see an increase in T1 values. This indicates that native T1 could be useful to define the appearance of cardiac remodeling in those risk populations, so give an indication of progression of the disease. For the other two risk populations, we had unfortunately not enough studies that we could include, so we cannot really give a reliable conclusion on the effect on native T1 of diabetes and obesity, but we would definitely recommend more research to T1 for those populations, to native T1. So we look at the main conclusions. The non-ischemic cardiomyopathy clearly leads to significant changes in native T1, which could be increased or decreased depending on the disease that you're looking at. For hypertension, without any left ventricle remodeling, we show that there's no significant change in native T1, which indicates that T1 could be useful to determine whether a person is only at a risk of developing into a disease or developing a different disease, or already has the cardiomyopathy. The results also showed a lot of variation in the healthy control populations, which seems to be very center-specific or even machine-specific. So we recommend specific reference values based on the machine and also the approach that you use. If you use a different T1 mapping, a fitting model method, or different ROIs. Furthermore, we only had a small number of studies that was performed to study diabetes and obesity, and this makes it very difficult to determine if the value of T1 mapping for those groups. So we would strongly recommend more research in that. But the main take-home messages are that non-ischemic cardiomyopathy leads actually to significant changes in native T1, that hypertension as a risk population doesn't have effect on the native T1. For more details on the meta-analysis and the approaches that we use, I would recommend you to read the paper, which is published in Journal of MRI and can be found under the DOI depicted in your screen. Thank you very much for your attention.